So we finally reached our last stage of our process, which is to finally create these real life images using the previous knowledge that we learned. So to use that, we use this application called Desmos, right? Which you guys saw already in some previous videos, which is a graphical calculator, which we can use to represent these mathematical functions and to create these real life images using linear, quadratic, and cubical functions. So how do we use our previous knowledge to apply these real images? As you can see here, we have the smiley face, and we learn how to graph a circle. So if we use the standard form of a circle, remember y squared plus x squared, 49 radius, create that big red circle. Then we can create a parabola to represent the smiley face. Remember our vertex, this is in the vertex form. And then what's interesting about here is that we can create our inequality. Because as you know, as we plug in a function, it goes on and on forever, it goes infinitely. So if we wanted to terminate at a point, for example, I don't want my y to go past -2 and past -5. So I put here -5 can be equal to or greater than y, and where y has to be smaller than or equal to -2. And then we can create our other two smaller circles. Remember, this one is smaller than this one because our radius is way much smaller. And this our radius is 7, and this one is the square root of 0.5. So for the red one, for the purple one. Another smiley face using our previous knowledge, our circle, circle, circle. Our nose is a circle again with a little bit of a higher radius of 1 in comparison to these, to the black and the purple one. Once again, our parabolas opening up. Remember, in our vertex form, A opening up. Then we have our big circle again. And this one is interesting. This is a water bottle, right? It's a water bottle sketch from a below eye view. As you can see, multiple ellipses. As you can see, it's getting smaller and smaller and smaller and smaller, the A and the B, as we go, as we're compressing it down. And then here we have some use of linearity, a linear x equal here. Once again, with the use of those inequalities, so it doesn't go on and on and on forever. You can either use a changing color edit from Desmos, right? And then we have another interesting water bottle here, in which you did multiple ellipses here to create that neck. Our bodies were formed by just linear functions, x equals. And then we have another small ellipse here. And of course, in this part right here, we have our sine graph, applying sine and the reflected over the y, over the x-axis sine. And we also have a parabola here. So this is a mixture of everything we learned. And this is the coordinates, right? For this one, if you want to create even motion to this water, I created motion, I made this move. But that's not necessary. You can use the I function. And here I have my ellipse, inequality, right? Our linear inequalities to represent that I want it to be between these ranges, between the range here. I have another ellipse here, another ellipse here, linear, sine or sine function with I to create motion. You don't have to create motion. You can just plug in sine if you want. Right there, the sine again, more sine, ellipse, and the linearity with our range. And I have another smiley face here. Everything kept constant. The only thing that changes is that the parabola is now opening down, represent a sad face. So the only thing we change, we put that minus for A. And as you can see, using knowing how to graph the circle with the high radius, understanding about the radius, then you can have smaller radiuses. You know how to graph this, have a specific range, know how to graph in vertex form, know how to find that circle. Depending, you can manipulate the radius. You can manipulate the parabola opening up or down, depending on the A. Remember, everything combined to form the smiley face. And then the same thing, but now we have a large hat, right? A fat hat right here. This time, only using everything constant, parabola up and down. This time, if you master linearity, just plug in the linear graphs here, all linear in the form of x equals horizontal, x equals vertical. Remember, y equals horizontal, x equals vertical, and within a range. I don't want this to pass. I want this between 7 equal to 7 and 15. Can't be past that. Same thing now, but we did a little smaller hat, right? Same thing, but we keep now our ranges smaller and the domain as well. As you can see, this vertical, this horizontal linear graph right here to represent the little hair. Can't go past, right? Our x now this time can't go past. It has to be between -2 and 2. Our blue graph has between, again, 7 and 15. But now there's a smaller distance, right? Since we have a -2, and then at this one we have 2 this time. and then it has to be between 7 and 15, and the horizontal here has to be in the y equals 15 line between -2 and 2. And now if you still haven't mastered yet parabolas, trigonometric functions, or conics, you can do a house just using linear functions. As you can see here, we only use linear functions to create this here, linear, in the form of x equals, this purple one in the form of y equals, x equals, y equals, x equals, y equals, manipulating, right? And if no, everything is easy. The only thing that you have to keep in mind is your inequalities. You don't want it to go forever. And the hardest part was, I think it was to create this proof right here. But if you know where your intercept is, where you wanted to touch, and a point that you had here, you can just find the gradient and you have the intercept, put it in slope intercept form, and you have your two roofs. This one is going to be with the positive slope, and this one with the negative slope. This is really if you master linearity. All the linear, as you can see, everything here is linear, 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 in the form of x equals and y equals. And that's really it, guys. All of our images created. Everything created here using linearity, conics, trigonometry, parabola, quadratics, everything that we've seen in our videos being applied here. And of course, we've seen many more, much more, but I'm leaving this free for you guys because you can really create anything you want. It doesn't have to be what it created. You can create a pig, you can create a tree, you can create a beach using those reciprocal trigonometric functions. You can really create anything you want. I'm leaving this open for you guys, but as you can see here, we have our functions, and now it's really up to you guys, so you guys can create anything you want. This is the end of our journey. Thank you all for watching, and hopefully we can create more and more later on. Hope to see you guys again. Thank you.